Thank you for joining us today's webinar. Good evening, good morning, good afternoon, everyone around the world today. Today we'll be going over performance testing in our CI/CD pipeline and just a bit of housekeeping to get out of the way. Let me resume my share here. Sorry about that. This webinar is being recorded, so we will be able to send this out shortly after we wrap it up. Questions, please add them in the QA box. Please don't write anything in the chat. I'll tell you we won't be looking at it, but we will. But please write in the QA box. And then we'll have a couple of polls, so please feel free to answer that too as we go through today's presentation. In our agenda today, we have what is performance testing, why we need performance testing in today's software delivery world, challenges of performance testing, how it fits in or doesn't fit in with CI/CD, and then how SmartBear and how LoadUI Pro look to solve the continuous performance testing challenge we're looking at today. Just a quick introduction. I will be leading today's presentation. My name is Daniel Giordano. I'm Product Marketing Manager on the API side. And with me today is Russell Viola, one of our solutions architects, our sales engineers on the API side as well. And we'll be looking at, again, an in-depth demo of running load test through LoadUI Pro in a continuous delivery environment. A short SmartBear introduction. SmartBear tools are synonymous with quality across the entire SDLC, from planning and design to testing and monitoring. We were founded in 2009, so nearly a decade of experience in Boston, Massachusetts, and have grown to over 11 global offices, encompassing North America, Europe, Asia, and Australia. Over 6 million developers, testers, and operations professionals from 20,000 plus companies use our tools every day to ensure that they deliver bug-free software. And our company is proud to have over 500 employees that seek to provide 5 free tools for the community. And we have 2 wildly popular open source solutions with SoapUI on the API testing side, and then Swagger on the API design and documentation. We are continually recognized by the largest third-party independent research and analyst firms for being the leading first look solution in test automation, API lifecycle, service virtualization, and more quality solutions. And we've recently been placed as leaders in the Gartner Magic Quadrant for software test automation in 2018. All right. So let's start with what is performance testing. Performance testing is going to be today the general name for tests that validate the behavior, performance, and sustainability of an application in production or production-like scenarios. We'll flip-flop a little bit back and forth between performance and load testing. There are some specific differences, so we will call them out. But in general, please just know that we will go back and forth, especially with the name being LoadUI Pro. All right, so why do we do performance testing today? Here's just a couple rundown of the reasons. Number one is giving confidence in our system and its reliability as we add new changes. This is something that we'll go over today, why we need to be doing load testing on every single commit and not just towards the end or seasonal, because there are things that will change. And it helps identify those bottlenecks that will happen with those code changes in the system under stress or load or spike, like we'll talk about. Performance testing also helps us find the limit of our infrastructure. So infrastructure is becoming increasingly more important, but also less important as we shift to the cloud. So as we move our infrastructure to the cloud, we sometimes shift the responsibility to, let's say, AWS or Azure to actually supply us with the amount of servers that can handle our load and scale out horizontally. But we really have to look at the architecture that's on top of that infrastructure, the application, and make sure that we don't find that before we're ready. Also find out the scalability of our system, like we talked about. Does that cluster, is that cluster able to scale underneath a sustained amount of load, or are maybe hardware failure? And then performance testing and running it regularly gives us the protection against poor performance in the future, and it accommodates complementary strategies for performance management, not only from a testing perspective, but also monitoring in your actual production environment. So let's look at some of the different types of performance testing that you might encounter. The first is going to be load testing. And again, this is kind of the most general one, but it usually requires a baseline that we measure against, and it's testing the performance of, and in this case, today's service layer or an API under a predetermined amount of load. So maybe 500 virtual users, but we're looking at some type of load pattern and actually testing against that for a baseline. The next is spike testing, which is exactly how it sounds. We are going to quickly increase the amount of load on an API over maybe a 1 second to 5 second interval, just to really see how the API handles a brief moment of intense load. This is actually not that common on, let's say, the UI side. You're not going to get a wide amount of users in such a short amount of time. Again, maybe after the 10.1% of Super Bowl commercials that really hit off. But on the service level side, you can definitely have architecture that is built where an API can be overloaded by one simple request. And there are parallel executions or service or jobs happening against that endpoint. So we'll see that happen where 500, 1,500 virtual again, access points users will hit that service in a very brief amount of time. The next is actually the opposite, and that's SOAK or endurance testing, and that's testing the performance of an API under load for a sustained period. So it's usually a max amount of people, and we're trying to test that system. Does it handle over an hour? Does it handle over a day? Again, of a maximum sustained amount of load, not a normal amount of usage, but maybe that brief 5-minute spike that we have. Let's stretch that out and see how the system handles it again over a 45-minute period, or maybe even over a 24-hour period if we're able to test there. And then lastly, we have stress testing, which is maximizing the amount of load on a system to find out when it will fail. So with stress testing, we're really looking to make the system, either the hardware side or our software side, fail in really any given way. And that's different where load testing, we're looking against the baseline. We're trying to measure against that number. And it might just be a 10% difference that we want to look at in that load test. Again, stress testing is really trying to maximize the amount of load and actually break the system. And during all of these, we're looking for different types of metrics, right? Maybe disk usage, CPU usage, memory leaks, operating system limitations. These are all happening at different intervals for, let's say, a spike test, where we really are looking for throughput and a bottleneck in one small piece. But then maybe on stress testing, or SOAK testing and endurance testing, we're looking more on the hardware side and actually seeing the health of our servers. Software delivery has evolved with consumer demands, and performance is a huge piece of that. Consumers are becoming intolerant of brand experiences that don't align with their own expectations. They need great functionality. They need high performing quality within the experience, let's say on a mobile device or on the web, both on the functional side with going through a form that works, but also on the performance side, where we're looking for, let's say, smoothness. We're looking for a type of speed and a type of reaction time that seems like a native experience. And software development has slowly, albeit, but has actually crept up and evolved to meet the needs of consumers. We have improved development and delivery methodologies. We have agile DevOps really starting to take an increased growth step. And we also have shift left testing. We have better quality methodologies. We have developers taking more responsibility of that in their everyday development. Yet performance testing has not really evolved to the growing needs of the market. We see so much about test automation and functional testing shifting left, maybe even security testing shifting left. But performance testing has really lagged behind the other types of testing in this adoption. Where load testing happens traditionally, and this is best case scenario, is towards the end of our SDLC, maybe in the staging or maybe even in this UAT server, but we're not giving immediate performance results back to our developers on a regular basis. It's happening on the right side of really, again, the shift left movement, and performance has still stayed in kind of this niche little space. So here, we're committing our code into a Git repository and kicking off the CI process. And we're running our first batch of functional tests on that QA server, giving immediate reporting back to the developer. But everything else is kind of taken hold into the actual ops space. So once those functional tests pass, it's kind of off the developer in this point. And traditionally, we've moved that onto the operations team to go run later stage performance tests, to go run later stage security tests against that service. But as we know, that comes with a ton of drawbacks, and the goal here is to try to move that testing earlier. Here, with Ready API solution, especially, we're able to move performance testing, security testing, functional testing against that API, against that service as early as possible, and also throughout the entire process. So here on this QA server, which is our first kind of level of defense for looking at performance results, we might have an environment that is pretty close to production. And environments is one of the things we'll actually talk about in its own slide. But we might have some virtualized assets behind it. So we run our first batch of functional tests that has a, let's say, a 90% level of accuracy against that service because the service, while virtualized, should functionally work. Performance testing on virtual assets, which we'll look at, may not be 100% accurate in this QA server space. We have some really cool tools that can make these services perform like in realistic scenarios on the performance side. But in general, it's still your first level. But we can run these performance tests and kick back results to the developer. And then we can continue as we move along in our DevOps environment and get a more production-like environment stage. So QA server, again, let's say 50% of our environment is virtualized, 50% is actual realistic. Maybe the staging server, we go up to 75-25. And then the UAT, it might be 95-5%. And that last 5% might just be a third-party service that we're using that is too expensive to actually load test in test. But again, we can get around that with some virtual solutions. So let's look at some of the challenges of today's traditional load testing and performance testing, and we'll actually look at some quick solutions there. And then our demo today will address most of these. So the first one is coming off fresh is environments. So first thing with load testing in test and early on shift lefting is environments tend to be expensive. So running 100,000 VUs in a testing session against a pre-production environment that has live connections, we can run up huge bills with services like Salesforce or SAP or any of these other payment gateways where, again, a lot of transactions are happening and they're live expensive APIs. So environments are huge challenge to performance testing earlier in the cycle, but we'll actually, we have Service V Pro, which is a service virtualization tool, and we have a lot of material on service virtualization and load testing, but it is the number one solution to improve your cost of environments and your availability of environments so that load testing happens earlier in the pipeline. So all these connections, whether they be third party or whether they be internal, we can actually mimic what they were like in real life and tune down the performance of each API to see their effects on the entire system. Next is test creation. Tends to be difficult. And we'll break actually performance testing into two pieces here with the test. The first is the test itself. So these are the steps that we'll take. An API, oftentimes it may be one step actually, and it's just an endpoint. But APIs still have end-to-end scenarios where we need to link up different API connections. And that step is actually the test creation here. The next slide, we'll talk a little bit about load generation. But most load testing tools are script-based. So LoadRunner, some of these more traditional tools you can think about, they actually have you maintain your performance tests in script, which makes not only access to just the creation in general, only down to a select few, but also maintainability difficulty increases. When anything goes to code and we base ourselves not off the model of, let's say, the service itself, but just written hard-coded code, maintainability as we make changes to the system really can slow down our performance testing efforts. And also, many times functional and performance testing, the actual test scripts are kept completely separate. So we're doing the same actions, yet we may have two different scripts that help us step through a scenario. One for the functional side and one for the performance side. And you'll see that that's kind of an unnecessary step, an unnecessary duplication, and we can combine the two steps there, functional and performance, into one test script. So next is the load generation itself and the load scenarios. And this is how we specify actual what the performance is going to be. So is this a really bursted piece of load that maybe has, again, 500 VUs over a 30-second period? Is this a load scenario that's going to ramp up over time? Every 5 seconds, let's add 10% more viewership to that service. And these things, aside from crafting the end-to-end test, this is also a challenge in load testing. And so one of the great things that comes with LoadUI Pro is actually pre-configured load profiles. So we're able to just quickly pick something like a variance or randomize or ramp up sequence on the right here. And we're able to apply those load profiles to our test so we can quickly move through scenarios. Load generation is also increasingly difficult with distributed architecture. Think about a load agent on the cloud or parallelizing your tests outside of that one machine. That's something, again, LoadUI Pro addresses with our EC2 agents. Another challenge with performance testing is data and sessions. Data is used in a multitude of ways on the performance side. So we not only have data going through the endpoint, so think about maps, payment info, everything that you can think about on the data-driven testing side of, again, that comes with functional testing and testing in general. But we now also have to deal with session info, with security and authentication info that's happening, again, in a widely scaled parallelized system. So we don't want to be logging in with that same session info on 500 different instances. We really want to have 500 totally different instances. So these are all the things where data really is important, not only, again, on the data-driven functional side that we always hear about with test automation, but really important on the performance side. And even more so on actually the UI side. We've just come out with a new tool in our performance testing category called Load Ninja, which really focuses, again, on client-side performance testing, where you can think about JavaScript session IDs and cookies really affect caching and then things like that on the front end. So this is becoming a more and more kind of focal point for challenge and solution here. This is kind of the crux of today's presentation, and that's shifting the performance testing left. I think one of the biggest challenges with load testing is measuring the efficacy of catching some of these these larger bugs and defects later in the SDLC process. So we're looking usually to catch load testing. Again, if it happens more than seasonally, it's going to happen right before we deploy, right before we actually get our entire environment into that production lake and are ready to stage for that production server. But that often means we're catching bugs at the absolute last moment where bugs are the most expensive. And with shift left bug discovery, we're starting to shift our entire testing activities left and into the development stage. So you can see here, instead of finding bugs later in the testing or even production phases, we're actually preventing bugs and seeking bugs in the development stage, cutting down greatly on the average cost of each defect. Developers can run unit tests, integration tests, end-to-end tests, load tests using test automation tools today in their everyday CICD workflow, and then they can actually hit, again, these realistic environments that can continuously be available through service virtualization. And then lastly is our metrics and analytics when we go to performance tests. For a lot of developers, for a lot of functional testers, performance testing metrics can be overwhelming. They're often just kind of dumped out in XML fashion, or they're dumped out as charts post session run. And again, it's a lot of information to wade through. But what we should be looking for, again, are some request times, timeouts, request pass fail, how many go or happen over that test, maybe that endurance testing time. We have a question here about assertions that can happen in the performance testing. So that's another thing. So not just the performance, maybe the number of 499 requests or the number of throughput against an API, but let's make an assertion against that throughput and measure that as well. So again, LoadUI Pro, we really address reporting and analytics in a big way, and you'll see that we can look at the test as it runs live, and we can also aggregate this data post-run, not only in our own desktop application, but also in a CI server type environment where maybe you might be using Jenkins as your performance and reporting dashboard. All right, so let's get a quick breakdown on Ready API, and then we'll actually check it out in Tool and look at running some of these performance tests against services. So SmartBear addresses performance testing and shifting left through LoadUI Pro, which is our API performance testing tool. Again, not only is it testing on the service level side, which allows us to catch bugs at the earliest amount we can compared to, let's say, on the web UI side, but also it is built in with many integrations around the DevOps ecosystem, allowing you to run these performance tests continually in a CI/CD environment. So it consists of SoapUI Pro. I'm not going to go through all these, don't worry, but it consists of SoapUI Pro, which is our API functional testing tool. And obviously this is SoapUI, the widely popular open source predecessor, but it comes with built-in environment swapping, data provisioning, and synthetic data generation for data-driven testing. We also have baseline end-to-end API tests and assertions that are just a right click and built in. LoadUI Pro, which we'll kind of go over in depth. Service vPro, which is our service virtualization tool that we also talked about. And maybe today we can actually light up a virtual asset and run a performance test against that. And you'll see that we're not just running it against a dummy mock or that we're going to get the same exact results from. We're going to actually configure some of the performance results of that virtual asset so we get realistic data back. And then just a quick, let me run through this. Sorry about that. Quick visual of what it looks like in a modern, let's say, CI/CD workflow. Here we have our feature code and our test scripts, all kept inside one Git repository. Let's say this one's GitHub. And as the developer pushes new code to Git, that's going to kick off our CI/CD process. So let's say we have Jenkins polling our Git repo looking for changes. That developer is going to start and kick that off. Well, then our CI/CD pipeline can go into action. And maybe the first thing we start up is service virtualization, and we begin the virtual dependency. And then once that dependency is actually lit up and built, let's go ahead and build the actual service and API that we're going to test directly against. Maybe you're using Maven, Gradle, something, Gulp on the node side. But anything there works with your CI and will actually stand up that service, stand up that API. And then once it's there, we're going to run our test against it. So we can run our load tests, our security tests, our functional tests against that built service, and then export results, either straight back to the developer. We can export the results in JUnit, HTML, CSV, really any customized format to, again, either go import into, let's say, your Jenkins instance, into a Git repo that can then be read by your developer, or into a reporting dashboard, something like Zephyr on the test management side. But again, this is a modern workflow for testing, performance testing against your API in the CI/CD environment. I just have, actually, that is it on this side. Now I'm going to flip this over to Russell, and we'll actually see LoadUI Pro in action, and we'll see it run in a Jenkins environment today. Let me stop sharing my stuff. All right, you're on.
All right, thanks, Dan. Again, my name is Russell, engineer over here at SmartBear. I work with all of our API tools, so anything from Swagger Hub, design and documentation, all the way through Ready API. So, working with all these, I get pretty familiar with some of the things that we do to push our process left. And I think we will touch on virtualization a little bit today, especially after we look at LoadUI, just because that's a big key component in pushing our load testing left, because our APIs might not be, in a staging environment yet. But if we're working with definition driven development, we can actually prop those up really early and then start this performance testing and start to build out more intricate tests, so that when we're in that staging environment, we'll have tests ready to go. So actually, we'll hop on the screen here, and I want to talk about LoadUI first. Here's kind of a finished product of what a load test might end up looking like. And this is fairly intricate, certainly not as intricate as we can get, but it's a good example. And I'll kind of show you how we started. You'll notice here on the left side, I have a bunch of what are called scenarios. And essentially, each scenario houses a target or multiple targets. And believe it or not, these are actually my functional tests from SoapUI Pro. So in order to really talk about how LoadUI works, it's good to touch on SoapUI just for a second. Now, we could bring in things for our load tests in other ways, right? We can create load tests straight from definitions. We can go straight from URLs if we need to. We can even use API discovery within Ready API to literally browse over our API, capture those endpoints, and create a load test. But the best way to leverage what Ready API is capable of is to build out these functional workflows in SoapUI Pro, because not only we're getting our functional testing and data driving our actual workflows with reusable variables and things like that, but we can take this entire workflow and then actually put it into LoadUI Pro, right? So everything that comes with this, all our validations, all our complex workflows and what have you, all that complex logic is going to translate directly into LoadUI, really with just a right click. So you could say, hey, I want to create a load test off of this test case, and we're up and running with this target. Now, some other things we can do and how we get this a little more complex is by, say, adding targets from directly within LoadUI Pro. And this is basically giving me a browser of all my projects, right? All my test cases that I've built in SoapUI to start picking from. So, say I have a lot more workflows that are going to kind of detail different client interactions, right? I can start to pile these up in my scenarios. So I'm slowly building out this more realistic traffic workflow against my API. And that becomes hugely valuable rather than just having, 20 concurrent calls that are just the same call. I actually have this real life interaction. I can chain these together in each scenario. And each scenario is going to basically act as a thread, right? So it'll play through my functional tests. And now when we think about, designing a bunch of different scenarios that house different functional tests and different workflows, I'm going to be able to run all of these concurrently in a way that I can, schedule them out, say, have one scenario running the whole time, have another kind of running opposite to that, pepper a few in. And because I can change each load profile on each scenario and even bring on individual assertions per scenario, we get this incredibly customized traffic to our service. So we can actually simulate edge cases and real world scenarios that we expect when we start doing our load testing. So I've got a few scenarios here. Each one kind of has its own load profile because I wanted to pepper in some stuff at different points in this load generation. And this is when I would start thinking about maybe putting on assertions. Right here, I have a time-taken assertion. Essentially, what I'm doing is with these is setting benchmarks for this expected behavior. So we kind of talked about this a little bit earlier, and it's basically saying, what do I expect my API to do under this amount of load? What is acceptable? We'll put in these constraints on something like test case runs. We can analyze the assertion failures from our actual functional tests even, and say, how many failures is going to be tolerated with this amount of load that we know is coming, right? So I'll say, all right, between 0 and 100, maybe, 1 or 2 of these is acceptable for the amount of load that we're generating. Maybe anything above that, is unacceptable. We're going to know that something's wrong. And this is going to trigger our test as a failure. So using these assertions is how we set up those benchmarks while we're running these complex situations here. Now, let's see here. So let's just take a closer look. I've got peak VUs here on my ramp up. Take a look at these as well. I think we saw these in one of the slides, but we have got quite a few options. We can even draw out custom stuff if we need to get really, really granular with it. But we'll stick with ramp up. So here I'm hitting 50 VUs by the end of my test. Here I have a base of 20, and I'm kind of randomizing at a factor of 50%. We're doing something similar with variance, although we can actually control the kind of wavelength of that variance. It's a little less random. And here we just have a burst. So I'm doing a burst every 5 seconds, right? About 15 VUs. And by scheduling these out, I'm able to, again, really, really customize that traffic heading at our API. Now, among just testing the API, right, we're going to get a lot of statistics, and we're going to look at those here in our statistics tab. But it's important in a lot of scenarios that I'm getting information back from hardware, especially when we're looking at situations where we might have load balancers in place, and we want to be able to actually see what's going on in those load balancers and how that's correlating with the performance testing of our API. or we just want to track the server that the API is on, so that when we're looking for bottlenecks and correlations, we can make sure that it's either an API problem, it's a server problem, it's a database problem, so we can hook up these monitors. And basically, I have a Windows machine here. I have a virtual service hosted on the machine, so I'm, testing this monitor, and I'll be getting information back. But we can connect to a number of things here, Unix or Linux with SNMP. We can connect to some SQL databases and what have you. And what this will do is say LoadUI will ping these servers every second during the load test and ask for the system logs, right? The kernel cache or what have you. And basically we'll get to drill down to that in our statistics. Now, one other thing we can do before we kind of look at these statistics is talk about distribution, because there's going to be cases where depending on the type of load testing we're doing, whether, maybe this is that SOAP performance testing, maybe we're looking at the stress testing, we're going to need to actually generate a tremendous amount of load in terms of simultaneous threads or concurrent threads, right? And there's a limitation to what we can do on one physical machine. So the solution here within LoadUI is to use LoadUI agents. And these can either be on a physical machine, maybe a server in our network, on other people's machines in our network, right, what have you, or even Amazon EC2 instances. So if we have existing Amazon EC2 instances, we can actually offset all this load generation completely to the cloud. What LoadUI is going to do is communicate with that instance, create an agent image out of the box, and we pretty much just have to configure that, select a region of many provided by SmartBear, and then we're up and running as soon as we select run scenarios on agents. So we would add a bunch of agents here. We can use as many as we need to because they're free on the website, right? These are at no cost. We already have a license, so this is really just a tool to get the concurrency that we need. So, I could have 10, 15, 20 agents, right? Start to divvy up scenarios and actually spread those amongst these agents here, just with the drag and drop functionality. And then I would look at maybe, assigning percentages of VUs per scenario and distributing properly that way.
And those agents, they could pretty much be any public or private cloud, correct? As far as let's say if you wanted to stick this in Azure, it's going to be pretty much the load agent gets installed on that service.
That's a good question. Yeah, so we can customize these to actually work with those custom clouds as well. Yeah. So now that we've kind of distributed our stuff here, we'll just run with, running on this computer for this instance, since I don't have any agents set up personally. We'll kind of, see how all this stuff comes together when we start to look at statistics. And we'll give this a run. So as we're kind of waiting for our load test, we'll see it going on in real time here on our dashboard, on our load preferences. And we can see some information below, right? We'll get a little quick first look at what's going on. If we're in our statistics page, we can actually view this stuff generating in real time here as well, assuming we've set up some statistics groups. And we'll kind of get into each of these that I've set up and see how we set these up to actually analyze our data in a really granular way. You can see in our first scenario, I have failures, scenario time taken, and test case runs. That's pretty standard. That'll be more or less the default when we're actually creating a statistics group. But when it gets really interesting is when we want to look at very specific things and just drill down to those without getting this fire hose floodgate of information that we have to parse through. And what we can do is say, all right, I want to create a new statistics group. Maybe none of this is important to me at all. I'll have access to my load test statistics, right? So maybe we want to say arriving VUs, assertion failures, executed test steps, and things like that. Right? I'll have access to each scenario and each of the functional workflows within that scenario. So if it's important to view the time taken of this request, completed transactions, how many times it failed, right? I'll be able to drill down to that specifically in each scenario that we have here. And this server monitor information that we're getting, right? When LoadUI is pinging that server, we're also going to get all those system logs. So if I need to look at disk percentage usage or memory consumption, right? Maybe I want to see how my available memory correlates to what's going on here in order to look for those bottlenecks. Now I can build out this custom chart, the statistics group that I can interact with, right? To really analyze these bottlenecks and really drill down and get to the bottom of what's going on with my API and the hardware that it's relying on. So I can create these here, right? I can drill down to this very specific level, this granular level, and totally home in on the information I want to see. I can build up comparisons as well. So we can compare old runs. Maybe we've made some changes in our API, and we want to view how these stack up against each other. We'll actually be able to view that stuff here, right? And then kind of play around with the information that we're seeing in order to draw those correlations. From here, we can export either in CSV directly right from here. We can build a report in either data export format, XML or CSV, or a printable report in PDF. When we actually make a report down here, this will be just our statistics groups, right? So we'll get a nice printout, a nice PDF of all the charts that we created, so we can send these out to folks and they can observe them. If we want a little more robust report, we would, we would look up here and you'll see we have a lot more options. So this is going to be more high-level information about our test. We can even add our history, we can add this flow layout, and we can put this out in data export as well, or a printable report. So it comes really in handy to have all these different options so that we can work with a number of technologies when we want to bring these results somewhere or even get them in front of just human eyes, right? So we have this human readable format. But, you know, we're limited here to doing this manually, right? At least from it within LoadUI Pro, these, you know, coming in and clicking the button and creating these reports. Luckily, we can get these via automation as well, because at some point, you know, we're going to set these up, and until some big changes happen in either the API or this functional workflows or our test composition, we don't necessarily want to have to come into LoadUI every time, press go and have this execute, right? That kind of isn't working with our Agile and DevOps methodologies. So that's when we start to look at automation and using this test runner. So the way that we automate with CICD with LoadUI is by generating a command line output that essentially we're going to be able to execute from any CICD tool, be it Jenkins, Azure, Bamboo, what have you. They'll all run this command line execution, right? So what we do within LoadUI is say, all right, you know, I want to run this specific test. I will point to the test runner on the machine that I'm trying to run the tests on. So maybe this is a Jenkins instance. Maybe this is a cloud machine. Maybe this is a VM. Maybe this is my personal computer, right? I'll have a ready API installation on there, and I'll point to that particular test runner that's going to live in that ready API installation. Now, actually, we'll hop over to ecom just because this is the one I actually have plugged into Jenkins today. So we can get a good look at, you know, the binaries, right? I'm pointing right to it. Now I can select from these different environments that I've set up in Ready API as well for an argument. These are pretty straightforward. Basically, what we would do, between dev, staging, QA, what have you, is we can click on this environments tab here, set up different environments with different endpoints and different database connections, JMS connections, and actually just select these from a dropdown during our regular testing. So we're just reusing tests for different environments. We're not actually creating new tests. Well, we can select that here as well, right? So maybe I have this webinar specific endpoint that I'm hitting, maybe a specific vert that I've created. I'll be able to select that here. And the rest of these are overrides. So by default, LoadUI is going to run what it's configured with, right? So whatever I've set up in my scenarios, as far as VUs, duration, failure limit, agents, all that is already set. And we would enter information here if, for whatever reason in our particular CICD environment, we wanted to override some of those values on the fly and kind of change them from within Jenkins or something like that. We'll also select where our reports are going and what type we're getting, right? So here I'm exporting some XML, including our statistics. I'm getting some JUnit and grouping those on the other side, and I'm pointing to where I'm actually going to export those to. I can do the same thing with individual statistics groups and point the CSVs out to export to grab later. And all this combines into this command line where those arguments are reflected with syntax that we can eventually get to know and kind of work with on the fly, perhaps even parameterize later down the line with some sort of script or something like that outside the tool before we actually put command line in a tool like Jenkins. So the automation options are pretty expansive when you start to look at it that way. And then we would actually, take this to our CI/CD tool, right? Here I have a Jenkins project. It's really just a simple build. We're just running this LoadUI test. And the way I have this configured in our build steps is basically by, hold on here, just give it a second. There we go. Right, so where I start to plug this in is I would add a build step of executing a batch command or executing a shell, depending on our operating system, right? I'll plug in the batch command that I've created, maybe eventually parameterize this, as I said, and then essentially we'll be able to run this from here, right? Point to our reports, be able to gather those in some way. And what we can do, let's leave the page. We didn't change anything here. Now we can kind of run this build. We can watch it in action and see what the load runner actually looks like when we're viewing the console. This is the kind of the feedback we'll get in our console anywhere that we use this. So if I were to put this in the Windows command line, it would get the same display back, right? This is just our command line runner. And we actually get a good little amount of detail here when we're running it, as we go, some feedback from the logs. You can see our overrides here if we had set those, right? And as we move along throughout the minute, we'll be able to see, how many targets we're hitting, right? How many failures are happening, even transactions per second, just as it's running. So this is like a minute-long test. I probably should have made it a little bit shorter. See if there's any questions while we're here.
Yeah, we can. Let me start asking questions. Actually, we have a quick one that will send us back to ready. But we have a question about whether this was get method or post method. And then this is a get method, I'm pretty sure. And then just asked about a data source. Mm-hmm. So if you just want to show like a data source getting thrown into the actual test case itself.
Oh yeah, sure. Yeah. All right. Well, we're coming up on the end of the test here, so we'll kind of finish this Jenkins portion. Basically, we get a final result here with what's run. Eventually, we'll hook this up to reports and have JUnit deliver.